Hello, thanks so much for joining us. In today's lesson, we're going to talk about solving by substitution. We're going to try and turn some words into math expressions, and we're going to solve them. We're going to use basketball, and at the end of the day, we're really going to focus on trying to figure out a hypothetical efficiency of a basketball player based on a formula that we come up with that seems to make sense for us. Okay, so the learning goals are really to solve expressions using order of operations, or BEDMAS. We're going to turn words into math expressions and solve algebraic expressions by substitution. So let's go ahead and get started. Now, before we actually start solving things, we're going to ask you to complete a magic trick, an algebra trick. We're going to ask you to pick a number from 1 to 20 and write it down. Carry out the following arithmetic steps out of the view of the coach. Now, the unfortunate reality is you're watching a video, it's not live, so you will not be able to confirm that we can guess this number that you have picked, but follow through with us. We're actually going to show you stuff and hopefully get you excited into coming up with your own magic trick with numbers. So whatever number you picked, again, it has to be from 1 to 20, a whole number, you're going to first of all double that number. So multiplied by 2. Once you do that, you're going to add 50. Then you're going to triple the result. So whatever you came up with, you're going to triple it. So that means multiplied by 3. Then you're going to subtract 100. And finally, divide this value in half. Now, you're going to come up with a new number now, and that's going to be your final result. And you're supposed to show it to your coach, only the final result. And then the coach can, in fact, use the magic of algebra to determine the original number that you picked at the very beginning. Now, because this is a video, you cannot confirm this, you cannot show it to your coach, but you could give us the final number in the comment section of this video. So go ahead and do that, and we will respond to every single final number and guess the original number. And we're actually going to tell you how we do that. And it's actually algebra. There's no magic here. It is math. So if somebody ever asks you this, you can be certain that there's no magic here. It is math. So basically, you were asked to do a bunch of things to some number x. So that x was the original number that you picked. We're calling it x. This unknown number. We asked you to double the number. So that's multiplying it by 2. We asked you to add 50 to the number. Then we asked you to triple this, multiply by 3, subtract 100, and then divide by 2. So this is basically all of the steps that we asked you to do to this number x that you thought about, okay? So for some of you, this may seem a little bit advanced, and it probably is, unless you're grade 8 or grade 9 and watching this video. But essentially, these are the algebra steps that we asked you to do to the original number x, this unknown number. Now, what we can do with this entire expression is we can simplify it by expanding it. Again, grade 8s and grade 9s would know this, and then collect like terms in the numerator. So in the numerator, we would get 6x plus 150 minus 100. Collecting like terms, we get 6x plus 50, because 150 minus 100 is 50. We have a common denominator here. We can, in fact, split this single fraction into 2 separate fractions, and then go ahead and simplify. 6 divided by 2 is 3, so we have 3x, and then 50 divided by 2 is 25. So that's really 3x plus 25. So essentially, we asked you to do 5 things to this number x. Double it, add 50, triple it, subtract 100, and divide by 2. Essentially, all of those 5 steps can in fact simplify into 2 things. Again, x is the number that you've thought about, this mystery number, and basically we can simplify that to multiplying by 3 and adding 25, 3x plus 25. So how would we guess this x, the number that you are thinking about? And basically, we can just go backwards. What we can do is we can subtract 25. So we can do the opposite. Instead of adding 25, we'll subtract 25 from the final number that you came up with or told us. And then we can divide by 3 instead of multiplying by 3. So we're doing the opposite operation in order to solve it. We did this in our last lesson as well, where we did opposite operations. And that tells us the original number. So I would ask you to try and come up with your own number trick where you ask somebody to think of a number. You don't have to do 5 steps to the number. You can do maybe 2 steps, add some number and then multiply by a certain value. And then all you would have to do once the person tells you their final answer is do the opposite or go backwards. And you should be able to come up with the original number that they thought about. And it should work every time. It's not magic. It is algebra. All right, so we were using BEDMAS a little bit here. We're definitely going to be using it today. But what is BEDMAS? It's nothing more than an order of operations when solving problems. We need it because if we didn't have an order, everybody would be getting different answers for certain orders, for a certain math expression. So everybody in the world follows the exact same order given to us by BEDMAS. B stands for brackets, E is exponents, D is division, M is multiplication, A is addition, and S is subtraction. So that is the order. Brackets go first, exponents, division, multiplication, and finally addition and subtraction are at the end. Also, we're going to use some letters in today's lesson. Letters in math are called variables. So in the previous example, I used letter X. That would have been a variable. Okay, well, other versions of BEDMAS also exist, and I will ask you to look it up online and try and figure out what the O in BODMAS stands for, what does P in PEDMAS stand for, and what does I in BIDMAS stand for. And you hopefully will get to learn other words or other names for exponents and brackets, because that's essentially what that is. Circle the variables in the following expressions. And again, try and pause the video here and answer these questions. We will go ahead and show you that X, Y, and Z are the variables. A, B, and C are the variables in the second one. And in the third one, there's a trick. C is a variable, R is a variable, pi is not a variable, it's a number. It never varies, so it is not a variable. Also, what does 5x mean? Does it mean 5 plus x, 5 times x, 5 divided by x, or 5 minus x? If you answered 5 times x, you're right. So whenever you see 5x, or if you see two numbers together, it's really multiplication in between them that's implied. Solving by substitution. So we've got an expression here, 2 bracket x plus 3 minus 7, and we want you to solve that if x is equal to 9. So we're telling you that x is equal to 9, and how in the world will we go about solving it? So the first step is replace that letter, the variable, with a value that you're given. Step 2, 3, and 4 will all require us to use BEDMAS in proper order, of course, and that's why we have BEDMAS to remind us of the order. But the first thing is to replace letter with the value. So instead of writing x in the expression, I'm going to replace x with 9, and that's what's shown here. And then the BEDMAS kicks in, and B is the first letter. Are there brackets? Yes, there are, so we're going to do those. Rewrite everything else, but solve for the brackets, and in this case, it's 9 plus 3, which is 12. Now we get to 2 bracket 12, and really what the bracket is now doing is separating the 2 and the 12. There's understood multiplication, so there's a multiplication between 2 and 12. So BEDMAS now moving on. There's no exponents, there's no division, we've done brackets. Multiplication, there is multiplication, so we're going to do that. 2 times 12 is 24 minus 7. So we're going to do the multiplication. We finished it. There's no addition. And finally subtraction. Yep, we've got it. 24 minus 7 is 17. Excellent. All right, now let's get to today's actual lesson that we're going to be utilizing this math and solving by substitution for. So you were playing a basketball game with your friends. You decided to use baskets, rebounds, and assists to get a total efficiency rating. This is hypothetical. Your friend said you can use the formula 3b plus 4r plus 5a to determine the efficiency of each particular player. So based on this information, what does letter B represent here? And it's, again, totally dependent on the question. And if you read the question, B stands for the number of baskets. R represents number of rebounds, and A represents number of assists. Keeping on with the exact same formula, what do you think is, what is the award for each basket? How about each rebound and each assist based on this formula that your friend has come up with? If you answer that each basket is worth 3 points, you're correct, because 3 here is together with the B and it's being multiplied by B. B is the number of baskets, so 3 times number of baskets is what's in the formula. Therefore, each basket must be worth 3 points. Similarly, each rebound is worth 4 points, and each assist is worth 5 points in this hypothetical efficiency rating formula. Okay, now let's go ahead and take a look at some math words. So here we've got 6 different expressions, phrases, and here we've got math expressions to match them. So try and pause the video and try to match. So write down each one of these math expressions as well as these word phrases and try and match them up properly. And I hope you have done that. Welcome back to the video. Let's go ahead and see if you've done it right. 2 more than a number really means, of course, that number that we don't know is x. 2 more than a number is 2 plus x. So if you guess that, good job. A number added to 2 is the other way around. It's x plus 2. So some number added to 2 would be x plus 2. The next 2 could be tricky. 2 decreased by a number would be 2 minus x because I'm decreasing 2 by some number x. The next one, the difference between a number and 2, that's x minus 2 because difference means subtraction. Number is written first, so the number x goes first and 2 goes second. Twice a number is 2 times x or 2x. Half a number is 1/2 x or 1/2 times x. So good job if you've got all of these correct. If not, maybe review them and make sure that you do write them out properly. Okay, so having gained that or having practiced that, let's try to come up with our own efficiency formula. So you're playing a basketball game with your friends. You decided that you will find players' efficiency score by adding all of the following. The first thing is you are going to add 4 to total assists. Then you're going to double total rebounds. You're also going to triple total number of baskets, hopefully not just one. And you're going to subtract turnovers from 2. So definitely we need you to first of all write an equation that can be used to calculate each player efficiency. So before we actually calculate them, let's go ahead and try and come up with an equation. So the solution is first by starting, we're going to start by assigning letters to every value that's needed. So A can represent assists. We'll need rebounds here. So R can represent number of rebounds. B can represent number of baskets, and T can represent number of turnovers. And now let's try and come up with a math expression for each one of these. So add 4 to total assists. A plus 4 can represent that since A is the number of assists. Double total number of rebounds could be 2 times R or simply 2R. Triple total baskets can be 3 times B or 3B. Subtract turnovers from 2 would be 2 minus T. And again, wording here is important. Subtract means minus from 2, so it's turnovers first. So turnovers from 2, 2 goes first. So turnovers are being subtracted from 2. So be careful here. That last one is tricky. It's 2 minus T, not the other way around. So the total player efficiency can actually be putting all of these things together. A plus 4 plus 2 times R plus 3 times B plus 2 minus T. We've put each phrase in brackets, well, the ones with addition and subtraction. You could also put the 2R and 3B in brackets. Actually won't make a difference in our problem at all. And then we're going to add them all up because that's what you're told to do. You're going to add all of these things together, and that'll give us the total player efficiency. Okay, so now that we have that, again, A is number of assists, R is rebounds, B is baskets, T is turnovers. After playing a game, here's some stats for a few players. And now you're asked to calculate each player's efficiency. So player Xabi had 4 assists, 2 rebounds, 3 baskets, 1 turnover. Abdullah had the following: Aiden, Sengi, Sungrab, and Etan. All of these are their stats. You should write these down. And your homework will actually be to try and figure out efficiency for each one of these players. But what we're going to do is we're actually going to practice with the very first one. So we're going to practice figuring out Xabi's efficiency based on his stats, and of course using the formula that we came up with in the last in the actual question. So this is a hypothetical formula. Different organizations will use different player efficiency formulas, and it is really important to know what the formula is because that's how people calculate each player efficiency. Anyway, let's go ahead and figure out Xabi's. So that's the formula again, just rewriting it, and we're going to do the same steps as we did in the previous example a few examples ago. So step 1 is always to replace letters or variables with values. Xabi had a certain number of assists. He also had a certain number of rebounds, baskets, and turnovers. and that was listed on the previous slide. So we're going to replace those letters with values. And then, of course, we're going to do BEDMAS and try and solve for his efficiency. So he had 4 assists, 2 rebounds, 3 baskets, and 1 turnover. So that is those, those are the replacements here. The R is 2, the B is 3, the turnover is 1. And of course, the first thing that we need to do is do brackets, right? So that's what BEDMAS tells us. So let's go ahead and do the brackets. I've got 4 plus 4 that needs to be solved, and then 2 minus 1. These brackets here are not actually operational brackets. They're just here to separate the 2 and the 2 and 3 and 3 from each other. We could have just written multiplication instead, 3 times 3 and 2 times 2, and that would have been the exact same thing. So they're only there to separate numbers, not for an actual operation. So 4 plus 4 is 8. 2 minus 1 at the very end is 1. And in between, we're just going to rewrite everything the way it is. And it's important that you keep rewriting things just so you don't lose track or forget to do something. So brackets are done. BEDMAS, we're doing it. We've solved the B. E, exponents, there are no exponents here. Division, no division here. And now we get to M, that's multiplication. And yes, we do have multiplication here again. The 2 numbers with no operation between them is understood to be multiplication. Going ahead and multiplying that, we would rewrite the 8, and then 2 times 2 is 4, 3 times 3 is 9, and then plus 1. Again, it's very important that you keep writing everything down so that you don't forget to actually do it. So we've done multiplication, then it's addition. Of course, that's the last operation. We don't have any subtraction in this step, and we generally do it from left to right. So 8 plus 4 is 12, 12 plus 9 is 21, plus 1 is 22. So Xabi's efficiency is 22. Your job is to figure out every other player's efficiency, and if I just go back to the last slide, is right here. Go ahead and figure out Abdullah, Aiden, Sengi, Sangreb, and Etan's efficiency using this efficiency formula, and submit your homework onto our online portal. If you're not part of the program, but you're just watching this video, do put the actual answers in our comment section and tell us which of these players actually had the best player efficiency. Hopefully you enjoyed this video, and we will see you next time with another math topic with basketball peppered into it. Have a good day.